Now we move to the almighty mitral valve. How do we evaluate the mitral valve? But first, we need to understand the anatomy. And we say the mitral valve typically has two leaflets, the anterior mitral valve leaflet and the posterior mitral valve leaflet. Anterior, posterior. However, clinically useful description of the mitral valve anatomy reveals that each of the leaflets has 3 scallops each, making 6 scallops for the mitral valve, designated as scallop 1, 2, 3, where scallop 1 is the most lateral and scallop 3 is the most medial. So we have the anterior mitral valve leaflets and the posterior mitral valve leaflets divided into 3 scallops, 1, 2, 3. And of course, both anterior and posterior mitral valve have their commissures on both ends, where we call the anterolateral commissure and the posteromedial commissure. All this description becomes useful when describing or when giving details at times where there is damage or where there is calcification in case of stenosis and the likes. It gives a proper description for surgical purposes of the mitral valve during echo. Also, the mitral valve evaluation involves viewing it from several views, such as the parasternal short axis mitral valve level, which is what we have here. You can see it's the fish mouth appearance of the mitral valve at the parasternal short axis level. Then we have the apical 4 chamber, apical 2 chamber, apical 3 chamber, subcostal, parasternal long axis. You can see mitral valve in quite a number of views. So moving to how to evaluate the mitral valve, we say alongside its very crucial role, which is popularly it's popularly known for, diastolic function evaluation, the mitral valve can be evaluated for both stenosis and regurgitation using any or combination of the following methods. We have mean pressure gradient, we have pressure half time, we have mitral valve area using Doppler estimation, we have MVA using planimetry, and we have the mitral deceleration time. Any or combination of all of these can be used to evaluate for stenosis or regurgitation of the mitral valve. And this is the mitral valve again, coapting. So let's take them one after the other. For stenosis, mean pressure gradient method of mitral valve stenotic evaluation. We use the apical 4 or the apical 2 chamber views by placing the continuous wave or the pulse wave Doppler sample volume at the tips of the leaflets, using color flow as a guide to ensure alignment of the sampling, like we've always said, and ensuring that it's parallel to the flow of the direction. The mean pressure gradient can be obtained by tracing the Doppler envelope using the VTI, from which the echo machine can calculate a mean value by averaging. All of this we are already familiar with. What are we saying? Once you place your Doppler sample at the tip of the mitral valve, it gives you your usual EA wave. So to get your mean pressure gradient, what you do is you take the tracing of the EA wave, which gives the VTI, calculate the instantaneous gradient across that tracing, and that gives you the mitral valve pressure gradient. So in this case, it's 1.9. So that's how you get your mean pressure gradient for the mitral valve. You trace